Okie dokie. Let's see, what we have here is oscillations. The top trace is the trace across the current viewing resistor, and that radical line right there is the zero line. The bottom trace is the trace across the quote-unquote battery at the rail. In this case, I've moved the bottom line to there. That's the bottom line right there. And the current viewing resistor is being displayed at 1 volt per division. 1 volt per division. And the battery trace is being displayed at 20 volts per division, and its baseline is there. So we have 20, 40, and then whatever peaks are there. So the midline of 48.8 volts is shown. Right now we've got about 140, 150 milliamps flowing through the system, and we are heating the load. That load is getting warmer. Okay, and the difference that we're doing right now is we're going to use the this capacitor in with the negative bias current. Okay, and I've made a little bit of a change with the negative bias part of the system. So we have the L & Co regulated power supply, and we have this is where I'm going to be breaking the circuit right there, and we have the 71,000 microfarad capacitor, and then we have this potentiometer arrangement. The 1 mega ohm pot that I was using just turned out to be too unreliable. It was a cheap potentiometer, and it was always over towards the end of it anyway. So this is what we're doing now. We have a 670K resistor in series with a 100 ohm 3 watt quality potentiometer, and then out of that potentiometer we have the 10.3 ohm series resistor, and then that goes to the function generator plus point on the board, and the other side, which is hooked to the positive side of the power supply and capacitor, goes to the negative function generator input at the board. Okay. Okay, and of course the function generator inputs at the board are the ones that we've always been using and the ones that are labeled on the standard diagrams: function generator plus, function generator minus, and we're bypassing the 50R resistor. That is not in the circuit. Okay. Alright, so that's what we've got, and we've got the oscillations. So of course what I'm going to do now is first of all, I'm going to just pull the positive lead to the power supply. So the circuit will only be seeing the capacitor as bias supply. Okay, ready? Here we go. Point. And then I'll plug it back in. It comes right up. Now I'm going to take the trigger off the real trigger point here, so that it doesn't die when it loses the trigger. Okay, so here I'm going to pull the positive lead. Okay, so you can see, I hope that, here I plugged it back in, I hope you can see that the oscillations are in fact powered by the capacitor for a little while until the capacitor runs down. And there's nothing's trying to recharge that capacitor, but we know that capacitors don't work in free energy devices. It has to be a battery. Okay, so I'm going to do it again. I'm going to unplug the positive lead. 1, 2, 3, 4, 5, boom, no oscillations. So you get about 5 seconds worth of oscillations from a 71,000 microfarad capacitor charged to about 8 or 7 volts or so. Okay, so there's our nice oscillations. I plugged it back in. Okay, so if I get the trigger again, there they are. Now the screen will go blank when the oscillations decrease to the point where the scope no longer triggers, but here I'm going to pull the power I think you can see there, I plugged it back in. I think you can see that the oscillations keep the same form, right, until the screen goes away. Alright, so here we go. Okay, so there we have the oscillations running off of a capacitor for the short period of time that the capacitor retains its charge. And we have a slightly modified potentiometer hookup to the board, because the simple 1 megohm cheap potentiometer, those are typically half watt, I think. She could not take the strain, Scotty. So there we go. Thanks for watching.